Okay, let's do a demand price relationship example. So let's talk about the Acme Manufacturing lawn sprinkler. So this thing has a fixed price cost to us of $55,000 per month. And variable price per unit of $15.5. Now the price demand curve, call it P. So P is a function of D. It's going to be minus 0.02 times D plus 87.5. So it's a linear line. I guess there's not any other types of line. So it's a line where P is a function of D. The slope is minus 0.02. So what we want to find out is, what is the optimum volume? And volume is just another way of saying demand. And the optimum demand is going to be a combination of our price demand curve and our total costs. So using our price and our demand, we could generate a revenue curve like this. And then we also have a cost curve here. And we're not looking for our maximum revenue. We're looking for our maximum profit. So what's our optimum volume? So this is our cost curve. And this is our profit curve here. And we could take our profits, subtract our cost. Oops, getting my tongue tied. These are our revenues. This is our revenue curve. So we could take our revenues and subtract our cost and get a profit. And that will then give us some value here. It'll end up being some value here, which will be our max profit. Now we could create a curve that's profit versus demand by combining our revenue relationship and subtracting off our cost relationship and turning in that into one relationship, which would also be a parabola. And then our D star would end up being here at the high point here. So this is the same max profit value as is over here. And in that parabola, we found that D star here was just A minus CR over 2B. And that's because our profit curve was this second order equation here for this parabola shown to my left, plus the A minus CV over D minus CF. So this midpoint here is really minus the second coefficient, which is this, plus or divided by 2 times the first coefficient, which is this. So again, this is our optimum volume. And we can stick in the values we have here given in our problem. Which are 87.5 minus 15.5 divided by 2 times 0.02. And just as a reminder, this is what we called A, or get that backwards. This is what we called A, and this is what we called B. Now make sure your CV is in cost per unit like we have up here, because in the relationship you need to end up multiplying it by the number of units, D, in order for it to give us a total variable cost. Well, this is equal to $1,800, so Acme does in fact make a profit. Or this isn't $1,800, this is 1,800 units. And our profit is going to be, we stick the number of units in our profit equation, minus BD squared plus A minus CV D minus our CF. So we end up with minus 0.02 times 1,800 squared plus our 87.5 minus 15.5 times D again, which is 1,800 that we calculated above here, and then we subtract off 55,000. So our profit then is equal to $9,800. So a question we might have is, well, what is our range of profitability? Well, our range of profitability is going to be the intersection of these two curves. And we could get that by setting these two equations equal to each other. And if you look back in the notes, that will result in a relationship like this. Minus A minus CV plus or minus square root of A minus CV squared minus 4 times the negative B negative CF over two times minus B. So it's just the quadratic equation. This is 1,100 units, and this is 2,500 units. So if we make between 1,100 and 2,500 units, we shouldn't lose any money. So that means we will make between this amount and And notice that by making the lowest amount, we would make the lowest profit. And over here, we would make a profit that wasn't the highest, but it isn't quite the low. It isn't, close to the lowest either. So we would make profits between here and here at these endpoints. But of course, if we make the sweet spot here, then we can get our best profit. That's not a great interpretation, really, of this. Those are the profits associated with the intersection, though. Okay. So, range of profitability is between 1,100 and 2,500. We could essentially come over to our profit curve and look at 1,100 and 2,500. And these are not necessarily evenly spaced here, but this would give what our actual profits were here. And say 2,500 over here to here. Okay. And actually, our break-even points are the points where this curve intersects at 0. Since this is our profit curve. And it was constructed using cost minus, revenue minus cost. And if we set that equal to 0, that's the balance break-even point. So I think a better description for these are break-even points. All right, so I'll end there.